Welcome to weeks 3 and 4 of this course on real analysis. We are now entering deep into the study. We are going to be studying the most important topic in all of analysis, convergence. One can directly proceed to study limits and continuity of functions without studying sequences and series, which is the topic of these 2 weeks. But the reason why we first study sequences and series is because sequences especially are far simpler to study than functions. In fact, what is a sequence? A sequence is nothing but a special type of function. It's a function from the natural numbers to the real numbers. It's a very simple function. You can talk about the first element, the second element, the third element, and so on. We study convergence of sequence. What this means informally is what happens to the sequence as you approach infinity in the natural numbers. We want to see if the values of the sequence get closer and closer to some particular value. If it indeed does, we call that value the limiting value. We prove a number of theorems for sequences which allow us to predict whether a particular sequence converges or diverges. The most important of this is the Bolzano-Weierstrass theorem. Not only is it important in the study of sequences, it is also important in connection with completeness. Indeed, when you are studying the various theorems in this particular chapter, please keep a close lookout for which properties crucially use completeness and which do not. This will greatly help your understanding. Once we have thoroughly mastered sequences, we move on to the topic of series. In fact, series is the more useful concept, but sequences are a very useful pedagogical tool. Apart from that, the convergence of a series can always be reformulated in terms of convergence of a sequence. Series are important from many perspectives. One of the most important perspectives, which we will see later in the course, is that all the elementary functions that you are familiar with, sine, cosine, exponential, can all be defined in terms of particular type of series called power series. In fact, if you have a pocket calculator, you will notice that when you press sine and enter a value, you will get the answer almost instantly. It's not because the values of the sine function are stored in the calculator's memory. Rather, a computation using an infinite series is being done. You can see the value of converting things into series once you start proving theorems about the functions sine, cosine, etc. later in the course. The famous programming book, The C Programming Language by Kernighan and Ritchie, in the very first chapter, talk about writing a very simple program that prints hello world to the screen. The eminent authors then remark that writing this program down, compiling it, and displaying the output is half the challenge of mastering a programming language. Just like that, these 2 chapters, even though it's only 1/6 of this course, is half the challenge of mastering real analysis. Studying convergence in the simplified setting of sequence and series, if you can master it here, everything else in the course would be relatively easy.